All right. Today's lesson, we're going to get a little crazy here. We're going to talk about imaginary numbers, something pretty much avoided. Algebra 1-2 class is going to be a new idea to you, so I'll try to take it slow and introduce you to something new. So on this page, I just wanted to remind you about. It's still related to radicals, so we're in this unit on radicals, in this case square roots. And so I want to remind you, square root of 4 is obviously 2, and the reason it's 2 is because 2 times 2 equals 4. Simple as that, right? These next two, you'll see that we have a negative inside. I'm going to start with, we just did 4 here, so I figure I'll do the same number, but now I put a negative there. And if you've been paying attention in here, you know that that can't be done. There is no number, there's nothing I could put here that then I could say that the same number twice multiplied together would equal negative 4. Because it's got to be the exact same number. It can't be one of them positive and one of them negative. It would have to be the exact same number. Well, positive times a positive is positive, and negative times negative would still be positive, but we're trying to get a negative here. So up until today, we would just say that doesn't work, or no solution. Right? No solution. But a while back, math people decided that we want to talk about it anyway. In other words, yeah, we know it doesn't make sense, but we're going to name it. And so here's the big lesson for today. It's all right here, okay? People decided, and we can define anything the way we want. So somebody came along, defined that the square root of negative 1, which really doesn't make any sense, because it's kind of like negative 4, only negative 1. It's just, there's no number times itself that can equal a negative anything. But this is the simplest form of that weird idea that doesn't exist, right? It's just a 1. And so somebody came along and said, I know it doesn't make sense, but we're going to name it. It's called I. And that's really the lesson for today, and we're going to build off of that. And I standing for imaginary, meaning not real, not good, not something that we really understand. But we certainly understand that we can take anything and put a label to it, whatever it is, whether it makes sense or not. I'm calling this I. So before we start doing some actual problems with this weird idea of I, we're going to talk about different powers of I and how that would work. So I is I. I is the square root of negative 1. That's the definition of it. If I asked you to break down these different powers of I, and I said, what's I? Well, I is I. Okay? Knowing in the back of your head that it equals the square root of negative 1. All right, but let's go to the next power. I squared would be the square root of negative 1 times this. We'll go backwards. It's I times I, which is the square root of negative 1 times the square root of negative 1, which ends up being negative 1. This is the next most important thing for this lesson, is that you understand that I squared, if you ever have that, actually is normal. It's not a weird square root of a negative. It turns out it's just negative 1. I cubed would be, how about I squared times I. But I squared, we just found out, is negative 1. And I, this is times right there, and I is just I. So this is negative I. So I cubed is negative I. In fact, before we keep going here, I is the definition square root of negative 1. I squared, of course, would be 2 of those multiplied together, I times I. But since we defined I as square root of negative 1, they're each that. And when you have the same thing inside of the same, if you have two radical square roots and they're the same thing in them, then the answer ends up just being that number that's inside there. And then from there it just kind of builds. I cubed is I squared. We already know that I squared is -1, so we write it as I squared times I, which is -1 times I, which is -I. I to the fourth is I squared times I squared, which equals -1 times -1, which equals 1. So I to the fourth, it also turns out to be a regular old number. The odd powers are going to still have to have an I in them, but you don't have to make it third power. You can bring it back down to just the first power. All powers of I can either break down to a regular old number like 1 or -1, or they're either going to be -I or just I in this case, right? So I to the fifth would be a good example of that. Now we're back to, it just goes around in a cycle. I to the fifth would be I to the fourth times I, but I to the fourth is 1 times I, and then that's I. And the cycle starts over. So the original I to the first and I to the fifth are the same thing. They're both I. And that'll keep going. I to the sixth is going to be just like I squared. It's going to be -1. I to the seventh is going to be I to the third. There's only 4 things. It doesn't matter what power I pick for I. It's all going to come down to either I, -1, -I, or 1. Now, one of the things you'll be doing in the lesson is just taking these like strings of numbers and i's like this. A lot of them will just be the first power of I, and this is the lowest stress problem that you've seen in a while, because all you do really is treat the i's like any other variable. They're not really a variable, right? They're the square root of -1, but we're simplifying, so we're going to try to keep it, we're going to combine these terms. So we have an I term here, an I term here, an I term here. So we have -5i minus 3i, which is -8i, plus 4i, -4i. So this combines to -4i. And then that 6 is all by itself, so we just put plus 6. And we're done. If it's a first power of I, there's nothing we really can do with that. It's just, we're going to leave it just like that. We're not going to put square root of -1 in there. That's just, we just know in the back of our mind that's what that's supposed to be representing. If I'm being very nitpicky right now, which I think I'm going to be, it turns out that usually the answers to these have the number first and then the I part. You know, obviously these are the same, but that's how you're probably going to see it most of the time, so I figured I'd mention that. It's the number, the regular number, and then the I. And any other power of I can be broken down to just a single I. So that every answer can end up looking like this. And you'll see some examples of that right now. Okay, so this is just a distributive property. Treat it just like I is x. You know, for a while, just do all the regular math, and then we'll go from there. So this would be -35i plus 35i squared. See, we got this times this. Just like it was an x, that would be -35, and then the I is tagging along. And then a negative, when we distribute here, the negative times the negative is a positive, 35 again. But now we have I times I, which is I squared. And that's where these problems change a little bit. If this was just an x, you'd leave the problem, that would be your answer. So it would be -35x plus 35 x squared. But I squared, maybe the most important idea of the day. I squared equals -1, period. Wherever you see I squared, you change it to a -1. So this is -35i plus 35 times -1. Can't do anything with the first power of I. It is what it is. But any other power of I can be broken down to something simpler. and then that's negative 35i minus 35, or negative 35 minus 35i. If we're going to write the number first, then the I, then it'll be written like that. Same idea. We are, this time we're going to FOIL it out. We got a binomial and a binomial, so we're going to do boom, We're going to do those four things, and then if there's any I squareds in there, then we'll change that to the -1, and it's just like any other regular algebra problem. There's barely anything going on here except the weirdness of it, that we're actually talking about something that doesn't make sense. That could throw you off. So we get 20, and then we get plus 24i plus 10i, and then plus 12i squared. That was just this times this was that, this times this was that, then this times this was that, and this times this was that. So normally we would just we would add these two things in the middle, which we're going to do for sure, and that'd be it. But with i's, that I squared again is -1. So how about we go 20, and then yes, we do have 34i, might as well do that now, and then this is plus 12 times -1. Now once you get the hang of this, you might want to just think of I squared basically as changing the sign, because that's what's going to happen here, right? We're going to get minus 12 now. So you might save a step in there and just write minus 12 right here. I'm just showing you, since this is only the few problems I've done, I squared is -1, and that's going to turn that into -12. So 20 plus 34i minus 12 equals 8 plus 34i. You know you're done with these when they fit the form of a regular number plus an I thing. There will never be any I squareds, I to the thirds, I to the fourths. They all can be broken down to just single power of I. One more. This is no different than the last one, but I saw a couple of these on the homework. I wanted to make sure you understand that 3 plus 2i all squared means 3 plus 2i, 3 plus 2i. So it's basically another foiling problem disguised. In other words, don't try to just square these two things. That's not what it is. It's this thing times itself. So it's that whole thing times that whole thing. Do a little faster this time. You get 9. Then you get plus 6i plus another 6i, and then plus 4i squared. Once again, that's this times this equals this. This times this is this. This times this here. And then this times this is that. Same idea as the last one. We now have these the same. And we know that this is going to be I squared. So I'm going to go ahead and go 9 plus 12i. And then I'm going to be a little fancier here. I'm just going to write minus 4. I think that's what most of you are going to end up doing anyway. So, the sooner we get in the rhythm of things, the more you'll see how this is pretty easy and a little bit fun. So this was -1, so that just basically -1 times this is -4. So it changes this to a negative instead of +4. And your final answer is 5 plus 12i. Once again, you know you're done when you just have it down to this format. The format is just call it A plus BI. That's kind of your standard form of any imaginary number. It has its regular number part, it's constant, and then plus something I. There's a few nastier things on the homework that we can jump in and look at, but the skills are already there. The number one thing. Let's review actually. Let me do one more page with the most important things. The first thing is that the definition of I is that it's the square root of -1. By doing some manipulations, we learn that I squared is -1, and that I to the third is -I, and I to the fourth is just 1. And then that pattern will continue. That's the only 4 things there are. It's either I, -1, -I, or 1. I to the 5th, it goes back to I to the 6th is I squared, I to the 7th is I to the 3rd, I to the 8th is I to the 4th. They're all the same thing. There's no other choices of what you'll get at the end. And that's why, and notice none of these have a power at the end. When you simplify them from a power, they just have either a first power or just a number itself. So that's why every problem we did, it never has to be left with a power of I in it. You'll never leave a power here. You'll always break it down to whatever thing it is. All right, so that should get you started. Work hard, be nice. I'll see you soon.